In our next lecture, we're going to talk about solving systems of linear equations in 3 variables. And we're going to use similar techniques that we used before when solving systems of equations in 2 variables. Primarily, though, the main technique is to eliminate one of the variables, and then you will have a system with 2 variables, and then you can use any of the previous techniques. So let me show you how this will work. So we have 3 equations here. And let's just sort of see which variable might be the easiest to eliminate. Okay, so here all the coefficients for x are positive 1. Here we have a coefficient of negative 1, positive 1, and positive 1 for the y's. And we have negative 2, 1, and negative 1 for z. So to me, it looks like eliminating the y might be the easiest, because what we could do is we could add equations 1 and 2, and that'll eliminate y. But we could also add equations 1 and 3 and eliminate y. So let's do that. So adding 1 and 2, what do we get? Okay, so we have x minus y minus 2z is equal to negative 1, and x plus y plus z is equal to 6. So if we add these 2 equations, we don't really need to do anything to eliminate the y. They're already just opposite in sign. So we get 2x, 0y, and then minus 1z, right? And then positive 5 here. Okay, so now we have an equation that only has x's and z's. All right, now if we add equation, so adding 1 and 3, similarly we're going to eliminate the y variable. So x minus y minus 2z equals negative 1, and x plus y minus z is equal to 4. So if we add these two, we're going to have 2x, no y's, but then we'll have minus 3z is equal to 3. Okay, and then now look, we have 2 equations, these 2 right here, that only have x's and z's. And so this is sort of, well, how do you solve this system? So if we can figure out what x and z are, then we can figure out what y is. So we can use any of the techniques that we had before, but let's stack these. Okay, so now we have 2x minus z equals 5, and 2x minus 3z equals 3. All right. Well, what could we do here? Well, we could either use a substitution method or we can do elimination. Now, do you notice that if I were to negate this second equation here, then I will get a negative 2 here, and then I should be able to eliminate the x's. So let's just do that. In other words, I'm just going to subtract, right? But what happens here? So then this will become the following. We'll get 2x minus z equals 5, and then distributing that negative, we'll have negative 2x plus 3z is equal to negative 3. And then now we can add, right? So adding, we eliminate the x's, and we have 2z is equal to 5 minus 3 is 2. So then dividing both sides by 2, we get z is equal to 1. Okay, so z is equal to 1. Okay, and then backtracking, we can figure out what x is, right? So we could plug into one of these equations this z. Okay, so let's do that. So 2x minus z is 1 is equal to 5. So substituting into this equation over here, right? 2x minus z, so minus 1 is equal to 5. Now we can figure out what x is. So 2x, if we add this 1 over here, we'll have 6. Divide both sides by the 2. X is equal to 3. And now that we have z is 1 and x is 3, we can pick any of the original equations and substitute in to get our y. So I'm going to choose sub z equals 1 and x equals 3 into equation. The easiest one to work with looks like maybe equation 2, but it really doesn't matter. You can pick any of them. So we will have 3 plus y plus 1, right? So x plus y plus z. So x is 3 and z is 1 is equal to 6. So then this is y plus 4 equals 6. So subtracting the 4 over, we have 6 minus 4, which is 2. So our solution is x is 3, y is 2, and z is 1. Alternatively, you could write that as a triple. You know how before we had pairs, or you could write it as 3, 2, 1. So just like before, how we would write them as pairs, here we have 3 variables, so you would write it as an ordered triple. So let's try to do another one similarly. Okay, so in this one we have 2x plus y minus 3z is equal to negative 14. X minus 3y plus 4z is 22. 3x plus 2y plus z is equal to 0. But which variable do you think we should eliminate? Well, looking at the coefficients, it looks like we're going to have to manipulate this kind of no matter what. So maybe we should eliminate the x variable. You know, that seems kind of arbitrary, doesn't really matter. Okay, so let's try to eliminate the x variable from 1 and 2 here. So eliminate x from 1 and 2. Okay, so let's do that first. So we have 2x plus y minus 3z is equal to negative 14. And then this second one is x minus 3y plus 4z is 22. If we wanted to eliminate x, what we could do is we can make a coefficient of negative 2 in front of the x, and then we can add them. So what I'm going to do is we're going to multiply this whole equation, the second equation here, by negative 2. Okay, so if we do that, then what do we get? So we'll have 2x plus y minus 3z equals negative 14, and then this will become negative 2x, and then distributing the negative 2 to all of these things, we'll have plus 6y, and then we'll have negative 8z, and then we'll have negative 44. Okay, and then now, if we add them, we're going to eliminate the x variable. So let's do that. So adding them together, we're just left with y's and z's, so we'll have 7y, and we'll have minus 11z, and this will be negative 58. Okay, so that's our first equation that we can work with. So now we have y's and z's, and let's do the same thing. We'll eliminate x from how about let's do 2 and 3. Okay, so we have x minus 3y plus 4z is equal to 22, and 3x plus 2y plus z is equal to 0. So if we want to eliminate x, what seems to be the best choice? Well, if we make a coefficient of negative 3 in front of this x, then that seems like it'll fix this equation so we can eliminate that. So what would we get then? So we'll have negative 3x, and then we'll have plus, so distributing the negative 3, we'll have plus 9y minus 12z, and that'll be equal to negative 66. And the second equation stays the same. And now we can just add these. So the x's will go away. We'll have 0x, but then we'll have 11y, and then we'll have minus 11z is equal to negative 66. And now we have two equations that only involve y and z. So what could we do there? Well, sort of looking at these together, we have 7 y minus 11z is equal to minus 58, and 11y minus 11z is equal to negative 66. Well, it looks like it might be easier to eliminate the z, because all we have to do is actually kind of negate this. So maybe we'll just take the second equation here and negate everything, or subtract them, and what would we get? So these two will have 7y minus 11z is equal to negative 58, and negative 11y plus 11z is equal to positive 66. And now if we add them, the z's are going to go away, but we're left with, so it looks like negative 4y and 6, 7, 8, right? So positive 8. And now we just divide by negative 4. And so then that means y is actually going to be negative 2. So how do we determine the remaining variables? Well, we're going to resubstitute this information in. Okay, so we'll substitute negative 2 into one of these two equations here. So we will have 7 times negative 2 minus 11z is equal to negative 58. So that's negative 14 minus 11z is equal to negative 58. So then we'll add 14 to both sides. So we'll have negative 11z is equal to negative 44, and divide both sides by negative 11. Oops, not 111. And we have z is equal to positive 4. And then finally, we'll just substitute these two things into one of the original equations. Doesn't matter which one you pick. Now sub this into 3. And what do we get? We'll have 3x plus 2 times negative 2 plus 4 is equal to 0. So that's 3x minus 4 plus 4 is equal to 0. So that's 3x equals 0. So divide both sides by 3, and we have x is 0. So the final solution is, well, these three right here. Okay? But we could write it as x equals 0, y is equal to negative 2, z is equal to 4. So that's one way to write it. Or we could write 0, negative 2, 4. So you could write it either way, as a triple or just writing them all out like that. And in our last example, we're just going to try to solve it the same way that we have done the previous two examples. So let's call this 1, 2, and 3. And let's just kind of eyeball the coefficients. Is there a variable that looks like it will be simpler to eliminate compared to the other ones? Well, not really, I guess. So, I mean, it is nice that this is already negative x, but you could also say because this coefficient is a 1, that's going to be easier to manipulate. It doesn't really matter. So let's try to eliminate x again. So eliminate x from 1 and 2. Okay, so we have negative x plus 4y minus 3z equals 2. 2x minus 8y plus 6z is equal to 1. So what should we do? Well, if we multiply the first equation by 2, then we'll be able to eliminate the x. So if we do that, then we have negative 2x. So distributing the 2, we'll have plus 8y minus 6z is equal to 4. And second equation, 2x minus 8y plus 6z is equal to 1. So now if we add them, what happens? Well, we get 0x plus 0y, so the y actually got eliminated, and the z got eliminated too. So this whole side is 0 equals 5. And hopefully we all agree that this is not possible, right? So this is impossible. So what's happening here is that we have no solution. Okay, so kind of like what happened when we had two equations. Okay, so because that happened, we can't proceed and try to find a solution. So what's the reasoning for this? Well, essentially, just like when you have two variables, those were lines in the Euclidean plane, and we were trying to figure out where they are intersecting. When you add a variable, these are actually representing planes, and the planes that are represented by the first two equations here are well, they're dependent. That's the terminology that we use, but they are essentially they're the same. So we can't find a place for all three of these to be satisfied simultaneously. Okay, there's not going to be a single solution there, and we get to this point where it's impossible. So we just say that there's no solution. So this can still happen in higher dimensions, but that's what we would say. Or another terminology for it is it's inconsistent. Okay. Yeah. I do want to mention though that they're not exactly the same, but what you actually kind of have there is two parallel planes. So like if you had two parallel planes, okay, and you had a third plane, let's say that one was the third plane, just to kind of give you a visual, you see that there's not going to be a single spot where these all intersect. Okay, when you have a nice situation, you don't want this to happen. If you want a single solution, you would have a plane for each equation, and let's say that here's another plane, right? And they intersect along that line. But then once you bring in a third plane, okay, now what's going to happen is the only place that all three are going to intersect with one another is at a single spot. Okay, and that's what was happening up above in these types of solutions, just geometrically. Okay, you don't really have to worry about this. Just if you get to a point where you get an impossible equation, you're just going to say that there's no solution. If you're interested in this, these types of things are exactly what you would study in a more advanced course called linear algebra.